Open Excel. Make a sheet called users. Add a column for name, one for email, one for country. Punch in a few more rows. Save it. Congratulations, you built 90% of what a relational database is. The other 10%, that part is what made banks trust software with your money. It's why your credit card swipe doesn't double charge. It's why your booking app doesn't double sell the same seat. In this video, you will understand SQL database the way you would explain them at a whiteboard. Tables, rows, columns, joins. Then ACID in plain English. Then the part most courses skip when not to use it. Let's get into it. A relational database stores your data in tables. Each table has a fixed shape. Rows are records, columns are fields, and tables can point at each other. That's it. That's the model. You have seen this before. A spreadsheet is the same idea. The difference is that spreadsheet trusts you. A relational database does not. It makes you decide upfront exactly what shape each table has, what columns, what types, what's allowed to be empty, what has to be unique. That upfront shape is called the schema. The schema is a contract. You write it once, after that the database refuses to accept anything that breaks it. Try to store a phone number in a price column. Rejected. Try to add a user without an email when email is required. Rejected. This sounds annoying. It's the whole point. Most production bugs aren't logic bugs. They are data bugs. The schema is a database telling bad data to go home. Stick this in your brain forever. A relational database is a spreadsheet with rules plus the ability to link sheets together. Everything else is detail. The language you use to talk to it is called SQL, Structured Query Language. You write a query, you get rows back. That's the loop. Picture a hospital record room. There's a cabinet labeled patient. Inside every folder has the exact same layout. Page 1 name, page 2 date of birth, page 3 blood type. Every folder, same pages, same order. If a new folder show up without a date of birth, the record clerk hand it back. Come back when it's complete. There's another cabinet labeled appointment. Every folder in there has a patient ID written on the top corner. The ID matches one folder in the patient's cabinet always. If you try to file an appointment with patient ID that doesn't exist, rejected. Now your hospital admin walks in and say, give me every appointment from last Tuesday, but I also want the patient name and blood type next to each one. The clerk does something specific. She doesn't go cabinet by cabinet and copy things by hand. She pulls the appointment from one cabinet, the patient from the other, and lines them up by patient ID. The output is the one combined page that didn't exist before. That operation is called a join. That clerk is your relational database. The cabinets are table. The folder layout is the schema. The patient ID on the appointment folder is a foreign key, and a combined page is a result of a SQL join. If you remember this hospital, you understand 60% of database interview already. There are 3 reasons relational database still rule almost 50 years after they were invented. Reason 1. Your data is probably already relational. Users have orders, orders have items, items have a category, posts have a comments. The world look like tables pointing at tables. SQL was designed for exactly this shape. Reason 2. SQL is one of the most valuable skills in a software career. Every backend interview asks SQL. Every analytics role asks SQL. It's the only language from the 1970s you will still write at your job in 2030. Learn it once, use it forever. Reason 3. The guarantees. When you run a SQL transaction, the database promises 4 things. We are about to break down what those 4 things means. That promise is why money apps hospital systems, and airline bookings still run on Postgres or MySQL today, not because they are trendy, because they are trustworthy. Here is where we are going. On the left, two source tables. The top one is user, three columns, user ID, name, country. The user ID is the primary key. That just means it's a unique label for each row. No two users shares the same ID ever. Below it, the orders table. The order ID, user ID, amount. Look at that middle column. That user ID is not the order's identity. It's point back to the user table. That's the foreign key. It's how the orders table say this order belongs to that user. Two tables, one shared column, that's the relationship. Now the magic. The query at the top right says select everything from users joined with orders on the user ID column. The database walks through the orders, look up each user ID in the user table and stitches the row together. The output is a brand new table that exists only for this query. Name, country, order, ID, amount, all in one row. That's a join. That's what relational means. A few more pieces to know. Indexes. An index is a separate lookup structure that makes searches fast. Without one, finding a user by email means scanning every row. With one, it's near instant. Indexes cost storage and slow down writes a little, but for read heavy queries, they are non-negotiable. Add transactions. A transaction is a group of SQL statements the database treats as one unit. Either all of them happen or none of them do. Which bring us to ACID. Imagine you transfer $100 from Asha's account to Mark's. That's two operations. Subtract 100 from Asha, add 100 to Mark. Atomicity, all or nothing. Either both balance change or neither does. The database will not stop halfway. If a server crashes between the two operations, the database rolls everything back when it wakes up. Consistency, no broken rules. The total money in the system is the same before and after. The schemas rules like balance can't go negative are enforced. The database refuses to land you in an impossible state. Isolation, no half-seen states. While your transfer is mid-flight, no other query can pick in and see Asha's debited but Mark not yet credited. To everyone else, the transfer either happened or it hasn't. There is no in between. Durability. Saved means saved. Once the database confirms your transaction, even if the power dies a second later, that change survives. It's returned to disk before the confirmation goes back to your app. All four together, every transaction, that is the SQL promise. I want to be honest with you about something most courses won't tell you. The good news, SQL databases are unbelievably battle tested. Postgres has been in production for 30 years. Your data is safe. Your queries are flexible. You can ask questions tomorrow you didn't plan for today. And ACID means you can sleep at night. The bad news, that rigid schema you loved. It's also the thing that bites you. Changing the shape of table on a live system with a billion rows is a real engineering project. SQL also struggles at extreme scale. Scaling a single database vertically gets expensive fast, and scaling it horizontally is hard. Don't use SQL when your data has no shape. Logs, sensor pings, blobs. Don't use it when you need internet scale and can give up strict consistency. For everything else, start with SQL. You can always move up later. Based on whatever we have seen, now you can answer these 4 questions. Question 1. What is the difference between SQL and NoSQL? SQL means structured tables with a fixed schema and ACID transaction. NoSQL means flexible document or key value pairs, usually with a weaker consistency and easier horizontal scaling. SQL is the default. NoSQL is what you reach for when SQL is a bottleneck. Question 2. Primary key versus foreign key. Primary key is a unique label for row in its own table. Foreign key is a column in one table that points at the primary key in the another table. Primary keys identifies, foreign keys connect. Question 3. Explain ACID in your own words. Automaticity. The whole transaction happens or none of it does. Consistency. The database stays in a valid state. Isolation. Transactions don't trip over each other. Durability. Once committed, it survives crashes. Question 4. When would you not use a relational database? When your data is unstructured, when you need extreme write throughput at internet scale, when you don't need transactions and you would rather have a horizontal scaling instead. That last answer alone will save you in interviews. Most candidates only know how to defend SQL. The ones who can also tell you when to leave it sound senior. Before you go, take 30 seconds to log this in. Takeaway 1. A relational database is a spreadsheet with rules plus the ability to link sheet together through keys. The rules are the schema, the link is a foreign key, the combined view across table is a join. Takeaway 2. ACID is a 4 promises a transaction makes. All or nothing, no broken rules, no half seen state, saved means saved. That's why we still trust SQL with money. Takeaway 3. Start every system with a SQL database. Switch off only with a real reason, schema-less, internet scale or write heavy. Anything else you will regret leaving Postgres. In the next video, we will get into NoSQL databases. Same problem, different shape. You will see when to walk away from SQL and what you trade for it. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.